point is 2, 2. Any questions here? Okay, so these distance problems all set up pretty much the same. Because we're going to use the distance formula here, that if we're trying to maximize or minimize distance, we're going to be using the distance formula. What we're going to do is we'll have one point that's given to us, and we'll have another point that's on the curve that we're just going to call xy. We do this, we set up our distance formula with the x and y on the curve, and then the minus whatever the points are that we're going to. And then we use the equation of the curve to get rid of one of our variables, whichever one's going to be easiest to solve for. Most of the time, the function will be given to us as y equals something, so we can immediately just replace it. In this case, we have to do a little bit of work to get one of the variables by itself. But there's no right or wrong way to decide which one to solve for. It's just whichever one you think is going to be easiest. Okay, so then we substitute it in. Then we have to take the derivative, and we can do it directly with a bunch of chain rules, or we can FOIL those out, and they always end up looking very similar. We just FOIL it out, end up with a polynomial inside there. Take the derivative of that, set it equal to 0. Now the distance formula will always give us the square root on the bottom, but the square root just gets ignored because we're just going to be setting the numerator equal to 0 anyway. So turns out that this numerator is always just the derivative of whatever inside here. You would get exactly the same value for y if you just left the square root off of this formula. If you left the square root off and took the derivative there, you would get exactly the same value of y. It's actually a trick that you can use to speed up the process a little bit, but get to avoid this messiness, this messy piece here if you take the square root off, but this is the only part that we care about anyway. So, okay. And I think in the watch it video, when they do a distance problem, I think they do leave the square root off so they don't do this part of it. So just keep that in mind if you're watching it and it doesn't follow along exactly what I did. It's just, they're just taking advantage of the fact that it's the derivative of the inside that we really care about anyways. Okay, any questions here? And then once you find one variable, then you use that to find the other variable. Go back to the equation and use that to find the other variable. Okay. Now in this case, it's, since it goes off to infinity in both directions, we don't need to worry about the endpoints because we know that they're not getting closer. For other problems, there's one problem in the homework that's an ellipse. And on an ellipse, it won't necessarily be, the endpoints aren't going off to infinity, so you have to check the endpoints in that case. And the endpoints, I don't know which, if you're solving it for x, the endpoint is the left endpoint and the right endpoint of the ellipse. Or if you're solving for y, it'd be the top and the bottom. Okay. So sometimes you will, even on the distance problems, have to do that, but this one we didn't because the endpoints go off to infinity. Any questions here?
I have a question. So where did you plug the y? Where do you go back to plug it?
Plugged it into this.
Oh, I see.
So let me give you one of these to do. Let me erase this part. Okay, so we have the line y equals 3x plus 5, and we want to find the point closest to 2. The point on the line closest to 2, 4. So we're going to be looking at something like this. Okay, so go ahead and do this. So follow along with what we did here. So we're going to set up our distance formula using the 2 points that are labeled there. Use the equation to get rid of one of the variables. In this case, it's going to be easier to replace y, and instead of this problem, we replaced x, and this problem, that new problem, it's going to be replacing y. But go ahead and do that. You can either take the derivative directly, or you can FOIL it out like we did last time. Take the derivative, set the numerator equal to 0, and solve for one of your variables. Plug it back in to get the other. Anybody has any questions, let me know. Come around. Anybody stuck? Not sure how to proceed? So when you're setting up your formula, those points ended up going there. So there are different points over here, so make sure you're just using the correct one. Otherwise, the distance formula is going to look exactly the same. Yeah.
So I have x, y squared, and that's what we did. That's what we solved. I don't even know, right? So
Right, so we need to solve for one of the variables, but this one's already solved. We can
Right.
just immediately replace the y in
Right.
your thing with 3x plus 5.
Right. But this, so now
this is just 3x plus 5 minus 4, so you can combine those terms.
Oh, because it's a negative, that's what I thought. I have.
Well, no, that was right. That's right, but now this is just 5 minus 4.
Yeah.
So it ends up just being 3x plus 1.
And then now let's go ahead and do the same thing where you foil this out. Combine like terms, you'll get something that looks kind of like this. And then take the derivative of it like we did.
So I took the plus 5 and plugged it into y. This is do I, does this go through with parentheses?
It does, but those parentheses are
Okay, so I don't have to like distribute this.
No, it's not multiplied, it's subtract. So this is 3x plus 5 minus 4, so you combine the 5.
Okay.
Yeah, when you replace the y, that becomes 3x plus 5. You have 3x plus 5 minus 4. You can combine the 5 and the 4 to simplify before you FOIL it out.
That's where I got, it's just the foil, the foil in there. And then I'll do this one.
You guys have any questions?
The y.
Yeah, it's only this part of it that you end up caring about, which is the derivative that's inside there. So we substitute in for the y. Since it's already y equals, it's really easy to do that part. And here, you can either take the derivative of this directly, or you can FOIL those out. Let's FOIL them out again. That's going to be x squared minus 4x plus 4 plus 9x squared plus 3x plus 3x. This is going to be plus 6x plus 1. So we're going to have 10x squared plus 2x plus 5. That's our distance. So yeah.
No. And seven x to the second. Minus
Okay, so
2x.
3 times 3 is 9. 6. 3 FOIL here.
Yeah,
3 times 3
no.
is 9.
Oh,
Okay. So now what do we do with this? Yeah, so now we take the derivative of this. And if you want to use the shortcut trick of just ignore the square root and work with 10x squared plus 2x plus 5 and take the derivative of that, it'll give you exactly the same value for x. So you can shortcut it that way. But I'm just going to take the derivative the way it is because it's not that hard to do. Okay, so. Okay, so 1 over 2 square roots times what?
X plus 2.
20x plus 2. Okay, so we just take the derivative. We have 1 over 2 square roots, that's the square root part of it, but then we just take the derivative of what's inside. And that whole thing needs to equal 0.
why is it 2 square root? Oh, because I already have a
That's,
square root?
well, no, that's our formula for the square root. Is
Oh, I see.
derivative of square root is always 1 over 2 square roots.
It's a 2 square root, not a second square root, right?
Right, this is 2 times the square root.
Okay.
Okay, and so we get 20x equals -1, or sorry, -2. X equals -2 over 20, which is -1 over 10. What about our endpoints? Are our endpoints going to possibly give us closest? Are the endpoints of our line going to be closer to this point than the point we got from that? Now, the endpoints are going off to infinity. They're not going to be close at all. So we know that the endpoints aren't going to work, and that's the only critical point we got. So that has to be our only value there. It has to be our minimum. so we get this, so we now, what else do we need?
Plug that into the original function.
Plug that back into the original function to get y. So y is going to equal 3 times negative 1/10 plus 5. Which is 47 over 10. So our point is negative 1/10, 47 over 10. If you want to, you can leave your answer like this too, I don't care. And WebAssign wouldn't care either, it would accept that for your y. Okay. Any questions here?
What did you say earlier? You said we don't need, before you went to the points, you said, can we get closer?
So the endpoints, we always want to check our endpoints.
Yeah,
So we have one critical point,
yeah,
and we also need to check the endpoints.
correct.
But the endpoints, are they gonna be closer, so our goal is to get close to that point, are our endpoints gonna be closer
Oh, I
than that one? Definitely not, so we can ignore the endpoints in this case, yeah.
So in the top right up here, you're setting the 20x plus 2 equals 0. And what are we doing with the 1 over square root of 10x squared plus 2x plus 5?
Nothing.
Is this square
That-
root, right?
It has nothing to do with square root, it has to do with denominators. So is this, we're taking advantage of this fact here. If we have a fraction and that fraction equals 0, the only way that's gonna work is if the numerator is 0.
Zero.
We can ignore the denominator when we have a fraction equals 0. So it has nothing to do with square root, it has nothing to do with anything other than the fact that in the denominator, denominators cannot make fractions equal 0 no matter what happens with them. Only way to attain 0 is to get the numerator equal to 0. If you ignored the square root here and just looked at 10x squared plus 2x plus 5, you would have skipped over this step and immediately gone to this step instead. That's all that does. It just saves you messiness in your derivative. But that messiness immediately goes away anyway, so it's not a huge savings. Okay. Any questions here?
So you said we can just leave it at y equals 3 times and all that stuff. But then how do we have the point?
It would just be, you could write it like this. You just look like it. WebAssign will accept that, I would accept that too. Not really care. Do the arithmetic. Or you can just plug it into the calculator and have it convert it back to the fraction. Okay. Questions, sir? Okay, so that's it for 4.7. The problems on the test are gonna be basically similar to something we did here. This distance problem is pretty straightforward. That is a very good type of test question. The one with the rectangle was pretty straightforward too. The cylinder, I probably wouldn't do something like that just because it's a little bit messy. But the problem itself wasn't that hard. It just gets a little bit messy with the cube and stuff. So. But any questions about it? Okay, so on Wednesday, we're gonna start on 4.9, which is bringing us to the end of the semester, and that's gonna be anti-derivative. So all of chapter 3, we were finding derivatives of functions. Chapter 4 and 5, we're gonna, 4.9 and later, we're gonna be doing anti-derivatives, which if we know what the derivative is, what was the original function? We're doing them backwards. Okay, so we'll do that on Wednesday. So any questions about anything? Exam number 3 is going to be a take-home exam, and I'll be passing it out next Wednesday, and we do the following Monday. Okay?
I'm be here, dude.
I will see you guys on Wednesday.
Where you gonna be?